Hey everyone, welcome back here to Techstrong TV. I've got a great guest. I've been looking forward since I originally scheduled this one to talk to him about because it's an area I've been writing and talking about it too. I want to introduce you to Don Murray. Don is the co-founder and CEO of a company called Safe Software. Hey Don, welcome to Techstrong TV. It's great to have you on here.
Yeah, thank you so much. I'm really excited to be here.
Good, good, good. So, Don, as I mentioned, that you're a co-founder CEO over at Safe Software, but give us. You weren't born there. What have you been doing up, until you co-founded Safe Software?
Yeah. The first thing that's probably relevant is I did my master's degree at Simon Fraser University in parallel processing, and then after that, I went and worked at McDonald Detweiler and Associates, who built ground stations, and I did some work on airspace modeling, and where I met the other founder, Dale Lutz, and then we a few years later we founded Safe Software, which is a company that is focused on enabling organizations to work with all kinds of data. Our specialty is anything that's spatial. So, i.e., for companies who have infrastructure on the ground, they obviously care where it is and they want to be able to analyze it and do all sorts of operations and connect it to the rest of their systems. And so that's a little bit about me and what Safe Software does. Yeah.
Love it. When did you found Safe Software?
Yeah, Safe Software is this company, a 30-year-old company that nobody heard of. Both Dale and I were technical, so we just spent time, building, this solution and then selling it. And then, much later we realized, really we need to really get serious about our marketing. And we sell around the world. Our first customer was actually in Sweden, if you can believe it. And we're based in Canada. And now we have on the order of 20,000 customers around the world, from local governments to airports to utilities. And again, any industry that cares about stuff that's on the ground is primarily where we are embedded. Yeah.
Love it. So another overnight success, you're telling me, huh?
Yeah, that's right. 30 years. I mean, and I tell people 30 years ago, I had amazing hair. And the
Me
funny
too.
thing is, yeah. And the funny thing is the older I get, the better it was. Right.
Yeah, exactly. And then I look at pictures from back then.
Yeah.
And it's like, my hair was always kind of thin. I mean, not like now, but it's
Yeah.
I never had that
No.
craziness. But anyway, hey, it happens to the best of us, Don, right? It is what it is. So let's talk explicitly about what Safe Software does. As you said, you gave us a little bit of background, but the world's changed. The world's changing every day. We're in this AI revolution.
Yeah, that's right.
As we sit here today, what's Safe?
Yeah. So we are, like some people said, oh, we're ETL, but we did ETL many, many years ago. Now we just build like data virtualization, APIs. We have real-time, high-velocity real-time, just connecting not just spatial systems, but all systems together. I guess you could think of us like the nervous system of companies. So we have everything from the top companies in the Fortune, 10 all the way down to the Fortune. Our market's like the Fortune 500,000, I guess you could say. And very big clients, very small clients. But they all have one thing in common. They want to get, more value from their data. So we basically chase data, so open table formats, for example, is a big thing. AI and connecting data to AI is critical because AI needs data both for training but also for inference, and we do in more kinds of data than anybody, and our whole model is any AI, because what is the best AI? It depends what you want to solve, and it depends the data you have, right? And the space is changing so quickly, so we want to give our customers that ability just to pick whatever AI, and we have some customers who are using 3 or 4. Just to solve different problems, right? Yeah.
So I mean, no one wants to be locked in, right? Locked in's a really dirty word.
Really, more and more, right? So people want flexibility. So was that a bit harsh?
Yep. For people who want to engage with Safe Software, maybe want to dig in deeper about what they're doing, how do they reach out to you, Don?
Yeah. So you can go to our website, fme.safe.com. We're technology people. We love talking to people about their data challenges. We have a free 90-minute, thing where you just show up and we show you how to use the product. It's a no-code platform, and if you want to try it, we just give you the software. So again, and we'll help you get value before you have to learn about it. We have webinars all the time with customers. And so, so just reach out. Happy to, to chat. Yeah.
Very cool. Don, if you don't mind, I want to kind of pivot and talk about our topic of discussion today,
Yep.
which is, that this whole debate about agentic AI is kind of irrelevant. What we're really seeing, though, is perhaps the extinction of what you call thin SaaS and vibe coding, and how this all fits in. Now, of course, Satya Nadella, CEO of Microsoft, he came out a few months ago and said SaaS is dead or dying. Killed by AI, right? We're seeing it in the stock market. Big SaaS companies, ServiceNow. A monster of a company. Their stock's down 50% this year. And they make their numbers. It's not like they're not making their numbers. Salesforce, kind of the granddaddy of, I don't know if I'd call that thin SaaS, it's fat SaaS, but Salesforce, one of the biggest SaaS companies, down 35% this year. What are you seeing? How do you see it?
Yeah, I mean, it's really interesting space because the key is you have to really have something. Having a database now with a thin UI on top of it isn't going to cut it. I was at an investor meeting where companies came and this company came out, I believe it was Bain, and they talked about how when they're looking at a company to buy, they actually hire 4 people to see how much of that solution they can create in 4 months. And if they can create a significant portion of it, then that tells them the company doesn't have anything, right? Because there's a lot of companies out there now that have a very thin veneer that you can replace. And for example, also at Safe, our sales team was going to buy a tool. And I said to them, why don't you try to just recreate it with Gemini? And these are sales guys. So these are not technical people. And they were able to create it themselves to the point where they said, we're just going to use Gemini. We're not going to pay the $80,000 a year for this other thing, because in fact, it was this very thin veneer on top of some other LLM. Might have been Gemini, might have been OpenAI. It doesn't matter, right? And so you need more than a good idea now. You need to really have something, something substantial, some secret sauce that, that really gives you extra value in the market, right?
I agree with you. I think you hit the nail right on the head. What we're seeing is, if I could recreate what you do using AI, I really don't need you.
Yeah,
right?
that's right.
We're even seeing it with open source software. I have a lot of friends who, big open source advocates, big open source consumers, who are like, hey, rather than dealing with the project and trying to get this functionality, into the main branch or whatever, I'm telling AI, this is the functionality I need, and it builds it for me. I don't need to use the open source software.
We're seeing that as well. Like our lead, and what's really interesting is our most experienced developers are the ones getting the biggest accelerator than the junior folks, right? Because again, they have that experience, they can see it, and so we're building an MCP server as part of our offering. And my lead developer, the guy's a genius. He came to me. He said, they're using Claude, and he said it saved him weeks of work.
Oh yeah,
right? And of course, he's a very expensive resource. So to save him weeks of work is amazing. And so now I'm thinking, those weeks of work. It's not like he's going to have weeks of nothing to do, right? So
he's going to do something else.
Going to be able to create. Yeah. So
I every Thursday I do a thing called Shimmy Says. Yesterday, Shimmy Says, I spoke about this. We're creating a world where some people are going to live below the AI poverty line. And then some people are really going to excel
Yeah.
and accelerate
Yeah. Yeah.
because the way AI works, if you are let's call it a master coder, like a real great coder,
Yeah.
the amount and quality of code you're going to turn out compared to someone who is a novice
Yeah.
junior and what they turn out with that same AI is going to be just, widely disparate. I mean,
Yeah.
it's got,
Yeah.
but it's not just code. It's the same thing if you're a writer. We
Yeah.
produce content here. It's the same
Yeah.
thing if you're a writer. It's the same thing if you're a musician. I don't know if you've had a chance to see the, synthetic music, they call it,
Sure.
AI
Yeah.
generated music. Well, in the hands of a real musician, it turns out crazy good stuff.
Yeah.
You or I, maybe not as good, well,
Yeah.
in the eye of the
Exactly. Yeah.
beholder. But
Yeah. Yeah.
I think that's, but it does beg the question though, is well, where do we get the next generation of great coders if the junior
Exactly.
guys
Yeah, I
aren't
was at an
here?
engineering company and this whole topic came up. They said, the people with all the experience find they don't need the junior people anymore. And I was like, well, when they retire, who's going to be, so as a company, you need to hire your junior people and grow them up because you're going to need somebody to oversee the AI and they do stuff like bridges. They're not going to take an AI generated bridge model and
And just let it roll.
somebody has to sign off on it. And,
Yeah.
and when bridges 97% accuracy is not good enough, right? You need, so anyway,
Yeah.
really, so we say the AI is an assistant, not the authority, right? And I think others have said that, yeah. So,
we've talked about it a lot around here at Techstrong and with people like you on Techstrong TV and some of our other shows. The way I look at it is fundamentally the job is changing.
yeah,
Right. So if you were a computer coder and you spent a good portion of your day writing your code, testing your code, squashing the bugs
yeah,
and all of that stuff, you're probably not going to do that. That's not going to be the definition of a coder tomorrow.
no,
The coder tomorrow is going to be the guy who manages the AI or gal who manages the AI who writes the code, but who, number one, could tell the AI exactly what I want out of that code, right? What
yeah,
functionality, what
yeah,
characteristics. And number two, has sort of, you know how coders are. When it's your own code, you can look at that code and you could see,
yeah,
you almost know it by memory. And if something's out of place, it kind of sticks out, right?
yeah,
You're going to have to be good enough to look at that code that the AI generated
yeah,
and see, oh, this looks good, right? And I'm not saying you're not going to test it. Of course, we'll test it, but there
yeah.
might be another AI that does the testing, right?
Yeah, that's right. That's right. Yeah. And so you think about AI generated code, it has two code reviewers because it has the guy who's writing the code. He has to make sure he understands it. And then
Yep.
every line of code here, we also have another code reviewer, right? And because code review is critical, because the most expensive part of code is not writing it, it's maintaining it. And we've had some pretty smart people here who could write really great code, but nobody could understand how it worked because it was so complex. And so from a maintenance standpoint, it was just too complicated. So we had to rewrite it in a simpler form that the mere mortal could understand it, right? And so, so it's going to be interesting. Right now everybody's using AI to produce code, but we're going to have to maintain it. You can't, so yeah.
I get it. Don, if it's okay, I want to talk a little bit about vibe coding specifically,
Yeah.
right?
Yeah.
It's funny. I was talking to a friend of mine the other day, very similar to your sales guy's experience.
Yeah.
He just decided, you know what? I haven't coded in about the last time he coded, he told me it was punch cards. So that should give
Wow.
you an
Okay.
idea. That should give you an idea.
So
But he said, I gave it a shot. And you know what? In about an hour, the hardest thing I had was not the code. It was just uploading the code to make the app run. And
Yeah.
once I got that done, the code ran fine. He was amazed.
Yeah.
Um,
Yeah.
this vibe coding we're going to go from, what do they think? There's maybe at most 50 million coders, 40 million coders in the world today. We'll have 1 billion coders or 500 million tomorrow with this.
Yeah. And
Or
so again,
developers,
AI,
not coders.
no, that's right. But AI also hallucinates in code, right? So it's going to be interesting how high a quality. I mean, our team uses vibe coding, right? But then of course and what we're doing right now is we have a no code environment. We're using vibe code to create the no code environment. Yeah. So then so we don't know what to call it. Is it a no code vibe?
It's
Vibe
a
code, no code,
no
but
vibes. I don't know. No vibes.
did
The
you-
absence of
Yeah,
vibes.
yeah.
It's
So
crazy. This is the
it's
world we
crazy.
live in, though. Now,
Yeah,
when you have
yeah.
monk bots finding religion and founding churches and everything
I
else that
heard,
goes
yeah. There's whole social media that are only for bots, not for
Yeah,
people, right?
yeah, yeah,
And they
yeah.
have their own language. I know it's
Yeah.
crazy.
Well,
Yeah,
no, now they want to encrypt so that humans can't read what they're talking to each other about.
nutty.
So,
Yeah.
you didn't think of this 30 years ago when you started
No.
Safe Software.
No, and all of us have been working with AI for many years, right? And then all of a sudden, Chat GPT, Gen AI landed, and that really was the game changer, right? We've been talking about machine learning and neural nets for years, and we had libraries we had used, but nothing like this, right? This is this is one of those big moments. And people talk about, is there an AI bubble? And I'm like, there was an internet bubble that burst, but the
Didn't
internet
stop
stayed
the
here.
internet.
The internet did not
Exactly.
go away. So
And AI's not going away either.
It's not going away.
There may be a financial reckoning, but
that's
that's
right.
another
But
story.
technology is going to stay. I mean, yeah,
But
absolutely.
I'll give you another scary thing. I wrote an article. I think it came out today on DevOps.com. So Claude released their latest opus, Claude Code or Claude Opus by Anthropic, Opus 4.6. Like within a day or two of it being released and the Anthropic people setting it free, setting it loose, it found like 600 vulnerabilities across these open source projects, across a whole bunch of important open source, not just obscure.
Yeah.
I don't know if we have the ability to deal with 600 new vulnerabilities every other, we just don't. We're not equipped yet. We're going to
No.
need AI to now respond to those
Yes.
vulnerabilities. And, so it really is a new game. It's a new world. A company like Safe, right?
Yeah.
You guys have been keeping current. And now
That's right. And we track vulnerabilities. And it's funny you mentioned that, because one of the mandates for that team is to find AI that can find the vulnerabilities in all the code that's being written, right? And also the testing and
absolutely. It's a great time. I mean, look, of all the timelines you could have been born in.
We were lucky. I mean, really, the PC was just powerful enough that two crazy technologists could start this company. And then the importance of data, for the last 30 years is only getting more and more important all the time. And now we're running out of data for AI. So we talk about synthetic data, creating our own data. I don't know if that's like synthetic oil for the car or not, but you get the idea, right? Like,
Oh, I get it. I mean, we're all looking at it. And I think, the irony of ironies is that we use AI to police AI. We use AI to test AI.
Yes.
It's a great time to be in here is all I got to say. Don, we're about out of time. One more time. What was that? What was the URL?
Oh, fme.safe.com.
fme.safe.com.
Yeah, perfect. Yep, awesome.
I wish you success for the next 30 years. But don't wait that long to come back here on Techstrong TV, okay?
No, it's been a real pleasure and great talking with you, Alan. Yeah, really good.
All right.
Okay.
Don Murray, co-founder and CEO of Safe Software here on Techstrong TV. We're going to take a break. We'll be back. Hey, everyone. It's Alan Schimmel, founder, CEO here at Techstrong Group. really happy to introduce this next session here for you. In this session, we are going to have Fernando Montenegro, who is the analyst in the security cyberspace, speaking with Ryan Jones. Ryan is the partner director of product for Power Platform Managed Platform over at Microsoft. Great conversation with Ryan and Fernando. Fernando's going to talk to Ryan as we explore how organizations can securely scale agentic apps, including Power Platform's governance capabilities. This is going to include managed environments, adaptive risk models, and lifecycle controls. Hopefully, you'll get out of this video practical guidance for balancing innovation with compliance in an age of AI-first development. Let's listen in on Fernando and Ryan.
Alan, thank you very much. So, I'm Fernando Montenegro. I am VP of Security Research over at Futurum, and I'm thrilled to be here with Ryan Jones to talk about the broader topic of AI governance. Ryan, want to say a few words before we get started?
Yeah, thanks so much, Fernando. My name is Ryan. I work on a number of the security, governance, and operational capabilities that we provide not only to our AI agents, but also that we provide to our low-code apps and automations that run on the Power Platform as well.
Have you come across something more specific to AI risks or AI governance concerns that surface above and beyond the data sharing, data flow and sharing and others?
As we look at the maturity of agents, we see that they kind of go from being assistants that are completely directed by humans to still interactive agents where humans are dispatching tasks, but the agent is completing them on behalf of the human. And then we see kind of those fully autonomous agents. And I would say that 10 to 20% is really more over on the end of the spectrum with those fully autonomous agents than it is with, like my little assistant agent or something like that. And the types of things that we see at that end of the spectrum are things like, hey, if I am collaborating with a set of agents, how do I understand what they are doing or what they are doing on my behalf? The second scenario that we see is we're in the very early innings of AI. And so there are lots of cases where agents need help, where they sometimes get stuck. And so some of the things that we've been trying to add into our products and our offerings are things like within Power Apps, we have the agent feed where a human can see what all the agents are doing for them. And then within Copilot Studio, the request information action, which actually allows us to define an agent such that it can engage with humans as needed.
So what has been your exposure, experience? What kind of considerations do you have in this topic of model drift and model security and so on?
Yeah, I think that it's funny. We talked about how what's old is new again earlier, right?
Yep.
We've had static tests that we perform against software for a long time. And what's interesting is seeing how that is evolving because models are less deterministic than traditional software. We call it, stochastic life, right? And so as a part of that, one of the capabilities that we've added to Copilot Studio is the ability to add tests and evaluations so that as our technology improves, as makers and builders go through and they modify what tools their agents can use or what knowledge sources are used to ground those agents, those test cases, those evals can run and can return a result so that folks, as they are evolving, they know whether or not they're actually improving the quality of their agents. Because what we find is that the first day that an agent is shipped in an organization, this may sound negative, but that's going to be the worst that agent ever is. Okay. It's only going to get better over time as folks refine the knowledge sources, as folks refine the tools, as folks look at and improve the success rate across those evals over time. And so I think that those quality gates that we've had in software for a long time, we have those with AI as well. I think also, a lot of times an individual maker, they're going to be the folks that are really interested in whether or not that agent really works well or not. While, IT is going to take a bigger picture look at things, right? They're going to want to understand in aggregate, how are things looking? Are they healthy or not? And it could be that if they see an agent that's not performing well, but, maybe just you and I use it, IT probably doesn't care. But if I have an agent that 20,000 people use this month, IT is going to care. And so those same views that we provide to our makers to understand whether or not their agents are healthy, we provide those aggregated views for the admins as well. In fact, had a large customer in the energy industry where someone built an agent, and it was for them, and they shared it, and it kind of grew and grew and grew. Next thing they knew, they had 10,000 people using it. They moved on to work on other things, right? IT was able to see and observe, oh my gosh, this agent is critical to our business. And so they took it over. They added it to their portfolio of applications that they managed. And the thing was, they saw it not as a burden, but rather as an opportunity, because there's an application that's out there that delivers value to tens of thousands of people in the business every month. And their dev cost up to that point had been zero. So it was a win-win for everybody.
Once the technology security teams build the guardrails, right, then the business users are free to go work on those use cases. So what kind of advice do you think would be applicable to those technology and security teams in terms of getting them ready to build or to build those guardrails or to leverage what they have to implement those guardrails?
I think enumerating the categories or the dimensions of risk is one of the first steps. There are huge categories of risk that these teams can eliminate through how they define policies. And to be clear, I don't mean policies like a Word document. I mean policies that are codified in the Power Platform and Copilot Studio and these sorts of things. Organizations don't want a random person in their company to build a workflow that takes information from their core ERP system and pushes it to Twitter, right? We have the controls that allow you to preclude that.
What would you consider to be, from a governance angle? You mentioned, okay, let's not focus on use cases. What would be advice for, okay, let's move this forward, right? Where are typical things that you see people, hey, let's do this?
I think the first thing that we see people do is they define like a zoned governance framework or a zoned governance approach, right? They decide within their company or their organization, what does green, what does yellow, what does red look like? And then they go through and they define that using the tools that we provide through the Power Platform and through Copilot Studio. I think the second thing that we see folks do is that helps with kind of the supply side, right? That sees to it that the technology is available and accessible for folks across the organization. But then there's this strong demand element. Because gosh, I was talking to another big company in the credit processing space a couple of weeks ago, and they had this amazing, governance framework set up, but they didn't do anything to stimulate demand, right? And so the next thing that we see is, reaching out to the businesses, not to harvest their use cases, but to help them implement their use cases, things like hackathons, things like training, things where for the people that are interested and excited about transformation through technology, where they can roll up their sleeves and get into it. I mean, the number of apps and agents and automations that came out of those couple-day training session and hackathons, it blows my mind every time I have the opportunity to participate in one of them. And it's fascinating because you see the passion of the people in the business. You see their ideas come to life. And then in many cases, that's the first step of a broader personal transformation and career journey, where you have someone that's been in accounts receivable for the last 2 decades, and all of a sudden they realize, oh my gosh, like I can actually harness AI to completely change how this part of the business works.
And what you highlight here is super interesting, because one of the things we talk about in the context of platforms is how you can have that network effect of you've already configured something in your environment for a particular use case, like I said, enter groups for identity, and how that can accelerate the time to value, if you will, within AI development, because hey, you're building on a foundation that you already built for your organization. So I think that's a really powerful message, right? And it's something that I tie back to: how do we help technology and security teams build that scaffolding so that those business users can go play with on those environments?
1,000%. And I think that in a lot of circumstances, it means standing on the shoulders of giants that came ahead of us, right? Like,
Yep.
what organization today doesn't have Entra deployed in one form or another for user and group management? And so why wouldn't we use those grouping constructs as a foundational capability around which we build our security and governance frameworks, right? Like, it's already there. It already works. And I think that is one of the things that's a little bit differentiating around the offerings that we provide in the space, because, I build an app, an agent, an automation from day zero. It's Entra authenticated and authorized, right? Another thing that we're seeing that's super common right now is as companies are trying to figure out how do they get these AI tools into the hands of people across the organization, and how does that center of excellence or that center of an enablement help people in the various business units upskill and drive transformation. One of the things that we're seeing is that our customers who already had a center of enablement or a center of excellence built out for low-code applications and automations, they're moving much, much faster when it comes to agentic transformation, because a lot of the foundational governance concepts that you need to have in place, they're modality or client agnostic. And so that's, I was talking with a financial services customer just yesterday, a big one of the GSIFIs, and they were like, yeah, we have deployed, this many thousands of agents over the course of the last, month, and we would not have been able to do that if it wasn't for the fact that we already had this governance framework in place from what we've done over the course of the last 5 years with low code.
I think that one of the areas that we want people to be aware of, like, and we talk about in our research, is that this evolution in models, right? We shouldn't be, just like you said about the use cases, just like the use case conversation, you shouldn't be waiting for the use cases before you get started, kind of thing. We shouldn't be waiting for a perfect model to solve, okay, once we have this model, this is how we're going to do this. No, because these models are evolving constantly, right? And if you architect your AI governance framework right, you build in or you leverage the monitoring capabilities to observe how a particular model is evolving, how a particular model is behaving. So yes, it is a critical component, like observing how these things are evolving.
Well, and it's interesting because I know that at times we've had discussions with some customers that are like, hey, how do I control which version of the model is being used by this agent? And, there are some places where we give customer those controls. But I will say, like, I'm kind of hesitant about it because I can't tell you the last time I talked to a customer that was worried about what version of the .NET framework or what version of Python I was using to deliver services to them. And so I think it's a little bit interesting that folks are looking for that level of control with some of these models. And I think that if we zoom out and ask ourselves, apply the good old 5 whys to why folks are looking for that. They want to make sure that as new models are available, it doesn't cause functional regressions in their agents. And the thing is, like we were talking about earlier, that's quite literally why we have tests and evals, right? And that's where, by the way, if for some reason, even though I don't think I've seen it practically speaking in the last year or so, if folks did see a regression as a result of a new model, awesome. At that point, yes, you want the control to go back to an older version, but we're not really seeing that in practice that much. So,
yeah, no, and it's this speaks this talk track of multiple tools for your SaaS apps within the business environments is something that it's a shared pain for security teams as well, because when we speak with security executives and their teams, they are swiveling between multiple tools on the environment as well. As a matter of fact, we're working now on a report on security platforms, precisely on that note. And one of the areas that we are tracking is AI for security, right? In the context of how do the agents that are now being deployed within Sentinel, for example, right, are helping with, okay, let's do exactly what we were describing from a low-code, no-code perspective. I know it's on the Power Platform, but we're seeing a similar thing on the security platforms as well. And there is tremendous interest in doing that, provided that, yes, we've handled the governance and risk constraints around those. So absolutely, this is a phenomenal time. The joke I make is that, listen, you can wake up at 6 o'clock in the morning, go to bed at midnight, and this stuff keeps coming at you with opportunities, right? It's information to collect, it's information to parse, and opportunities to make improvements. Perhaps you can use agents to help you with that too. As you're thinking about how you're evolving the Power Platform, and what have you been looking to improve in terms of security and governance capabilities on the platform? Where do you see the platform going in terms of one of the things that, and this is more of a higher end use case, but we do see requests for regulatory compliance.
Like, remember when the internet was new and people started creating like those blogs that talked about like what they ate for lunch or what their dog did that afternoon because they didn't know what else to do with it? I kind of feel like we're in the same place right now with AI. And so I would definitely want to preface anything I say with these are early innings. And so I kind of don't know. Okay. At the same time, as we look at, the types of regulations that are coming into play with the EU AI Act, some such examples that we're seeing there are like, hey, these particular types of data need to be handled in a particular way. And one of the things that we've started doing within Copilot Studio is surfacing those data labels, those information protection labels in the response so that folks don't inadvertently start working with sensitive data in a way that they don't intend to. And I foresee that in the fullness of time, this will continue to grow. Like one of the things that we're seeing is we have a capability in the platform today called Advisor. An Advisor constantly scans over the agents and the apps and the automations to make recommendations in kind of like a reactive governance or reactive security perspective, because we believe strongly in the principle of trust but verify. And one of the things that we're starting to see with Advisor and the way that it can iterate through, like AI-generated app and agent descriptions, is we can actually start to flag when some of these apps or agents may be getting too close to that boundary of what, acceptable use policy within a company looks like. And so there's definitely something interesting going there.
So one of the areas that when we speak with security practitioners comes up a lot is they are balancing two very distinct problems. On one hand, they are absolutely swamped. The other is we need to balance two things. On one hand, we want to use as much as possible of the broader tooling we already have, the security platform conversation that we are observing, right? That being said, there's still, in many cases, particularly the more novel use cases, there is a need to work with third parties. What's been your experience navigating this platform and ecosystem scenario in the conversations you've had as people have been using your platform?
Yeah, I think that what we try to do is we try to start from, first and foremost, providing those foundational security primitives that people need to be able to leverage these capabilities safely. And that has to be native within the platform, right? Like if I have to go find an authentication provider or find an authorization service or figure out my auditing and, those sorts of scenarios, like that's a non-starter, right? And so we have to provide those capabilities from the get-go across Power Platform and Copilot Studio. I think the next layer above that is if I think about the tools that someone in the CISO's organization is using on a daily basis, I'd love to think that they come to the Power Platform Admin Center every day, but I know that's not true. Right? They're spending their time in, Defender experiences. They're spending their time in Sentinel experiences. And so it's critically important that all of the telemetry, all of the audit logs, and these sorts of things naturally flow into those systems because we have to meet those security professionals where they are. And then I think the final thing that we're seeing is there are some unique and novel risks in some cases with AI, right? When we look at things like prompt injection and, kind of the emerging product categories of like XDR for AI, does Microsoft have some solutions in that space with Defender? Yes. Is it also such a quickly evolving product category that we need to plug into the broader ecosystem? Yes. And so, the same extensibility hooks that we use for integrating with Defender are actually the exact same APIs that we allow partners like Zenity to connect to so that they can provide additional defense in depth when it comes to particular risks like prompt injection.
Ryan, this was a phenomenal conversation. Thank you so much for the time.
Hey, thank you so much for your time and for all the awesome discussion. And, my hope is that folks, as they hear what we discussed today, they'll feel confident, they'll feel empowered that they have the capabilities needed to manage that security, governance, operational availability risk, and that they'll be able to parlay that into, accelerating how AI is able to transform their business and deliver outcomes for their employees as well as their customers. Can't wait to see what's next.
I think that as I ponder on what we discussed, a few things first and foremost, this notion that you have been building a platform to begin with in terms of low code, no code before, and then building the AI capabilities on top of that does give people the benefit of building on what they've already done. It does give the benefit of tying to the rest of their ecosystem, and it's as much about the culture of let's try and get started and work on different types of use cases without trying to boil the ocean. We're going to build a capability that accommodates different use cases, different levels of governance requirements, right? And then we're going to help those teams start to work on those particular scenarios. I look forward to seeing how the platform evolves and capabilities. This area never stops. One of the taglines I use is there is never a dull day in this industry, and that's the case here.
Hey guys, thanks for the throw. We're here with Nigel Douglas, who's head of developer relations for Cloudsmith, and we're having a little chat about, well, just how secure is all this code that we're creating with these AI tools, because, well, turns out there are a lot of issues to think through here. Nigel, welcome to the show.
Thank you very much for having me.
I think everybody at this point who writes code has at least experimented with an AI coding tool if they're not using it every day, but I get the sense that not everybody kind of understands like just how insecure these things are. For example, an indirect prompt injection attack can be pretty lethal. What's your assessment of these tools right now from a security perspective, and what should developers be looking out for?
Yeah, that's a few things. I think the main thing we need to remember about all these systems when we're talking about large language models is that they're probability statistics models at the end of the day. So it's really about predicting the next word. When we think about that nature and the fact that it's non-deterministic, it means that if we ask the same prompt 10 times, there's a chance 9 people get more or less the same answer and one person gets a different answer. And that different answer is really between, am I pulling a software package or using code that doesn't make sense, it's not real, it's fabricated, versus 9 out of 10 times it's something that genuinely exists in a code base and is reproducible.
And it also seems, though, that the bad folks out there that are trying to compromise our software supply chains are getting savvier about how to fool those LLMs into doing things that we don't want them to do. So is the software supply chain as we currently know it going to be much more easily compromised?
100%. That's a point that adversaries will always look at. So if we think again about it being a probability system that's trained on existing data, we have to think, where's that data coming from? The likes of GitHub or Reddit. And if I were an adversary, what I would be looking at is, again, in the case of typo squatting, does a package exist that sounds like a plausible package that someone's going to ask for? And if it doesn't, what if I started fabricating these packages and creating and uploading these packages in public upstreams on the basis that eventually an LLM might say, well, here's a suggestion, why not try that package that I know exists somewhere? But of course it's not good, it's full of malicious code. So that's a thing that's expedited by LLMs, is this concept of slop squatting, this idea that, look, if we rely blindly on the output of AI slop, we don't know what we're taking, we're just asking and applying. You may be susceptible to pulling something that an adversary is put there deliberately in the hope that you consume it without thinking. So yeah, I think LLMs, it's a fact at this point, are expediting risk in a few different ways. The deliberate element where adversaries create malicious packages on the hope that someone accidentally consumes it via LLM. But then there's the other side of it, which is, when I started working with Kubernetes, I take samples from the docs and I apply and I start making changes based on deliberate decisions, which is, maybe I want to only give access for specific scope, from a network policy perspective, maybe I only allow ingress traffic and no egress out of it, and these kind of decisions. When it comes to AI, if you just say, create me a workload, it doesn't immediately say, well, I'm going to create the workload with these security considerations in place, because unless you prompt it and ask for that consideration, people are blindly consuming code that is generated that is arguably insecure. And that's not deliberately to be insecure. It's just, it wasn't part of the prompt consideration. So yeah, there are so many things to think about from a security perspective that I question our developers primarily focused on the security aspect. I would say probably not.
Mm-hmm. Are we just waiting for some sort of cataclysmic event then before we all wake up and smell the coffee? Because right now it seems like, everybody and his brother's so obsessed with the productivity gains that nobody wants to talk about anything that might be, well, shall we say, a downer.
Yeah, I think we may have had that incident in the last couple of days. So, there's one element when we talk about the likes of the Claudes and Cursors, these tools that already exist, but people keep pushing towards, can I have it do everything for me? This fully idea of agentic. If I could ask an AI agent, go and do something and just run it as a background task, will it make me more productive if I'm just on autopilot, I'm not involved? And you may have heard the OpenClaw project that came out, and well, it's grown in popularity in the past 2 weeks. But essentially what you were doing was running this on your local hardware and saying, here's root permissions to go and be agentic and do what you need. And of course, a lot of people were compromised in that time. People are pulling skills from public repositories because it's all done for me. This is fantastic. And of course, we don't know what's bundled in those skills. We don't know to what extent this agent will operate. Will it accidentally delete something, or will it deliberately delete something? And what impact will that have on us as an organization? So yeah, these are the sort of incidents that are happening now, is this blind trust of, well, if it's AI, it's going to be better than me. But what if adversaries compromise that? So yeah, that's probably the first real example we've seen so far.
And we don't even know what other AI agents those AI agents might be hanging out with, because my AI agent could be perfectly benign, but those other ones could be fairly malicious, right?
Yep, absolutely. So the idea here with this OpenClaw is fundamentally it's open source. So anyone's free to contribute. So the idea of any type of hub since the beginning of time, if we think GitHub, or we think of Python's PyPy or NPM for JavaScript, all of these are public repositories where it's fundamentally the core control of open source is that anyone should be allowed to contribute. But if I'm bad and you're good, and you're going to your effort of creating something for community and you're uploading it for goodwill, and I'm just making malicious things and calling them similar names to yours, for every good thing that happens, there's always going to be bad things. And I think the same's happening now with AI. The difference now is the development is so fast. I don't think people fully understand what these models are, the data sets associated with these ideas of skills, that if I want to play around with AI, I'm just going to grab everything I can find off the internet. And of course, I have no idea what I'm downloading at that point unless I actually understand what these models are.
So what are we supposed to do about all this? Because I don't think we can put the AI genie back in the bottle at this point. So are there things that organizations need to implement, especially, say, the DevSecOps teams that are ultimately responsible for all this stuff? And how hard will it be to do that?
Yeah. So I mean, there's a lot of things we can think about. I always think about having clear controls that are consistent and static in some way. So policy is always a good one. So a type of rule you can set in your organization is, again, this is where someone like Cloudsmith comes into place, where we say, if you are pulling everything from your own private registry, assuming you audit everything that goes into your private registry, but at least you can put the control there to say, well, we only allow our developers to source from this private registry. So this idea of everything coming from public registries and we don't know what's in them is a real problem, because we don't know what we're sourcing at the end of the day. We don't know what's running in our production systems. That's the world we don't want to live in. Then aside from just saying, I want to source from private, you also want to, as part of that registry control, you want to have some kind of automated guardrail in place that's going to do the scanning to tell us what is or is not defined as good. So when it comes to AI, again, whether you think of something like Hugging Face, we have these models and data sets, and we have essentially Python scripts at the end of the day to do this statistics. We just have to understand, well, what of those have certain file formats? Which file formats can, for instance, be executed? Should we scan them to see if those executable files are potentially containing something that's deemed malicious? So there's all sorts of open source projects that have existed. You can think of the, Clam AVs of the world that could scan and say, I see a signature that I don't trust and that is therefore bad. But then there's also projects like the OpenSSF. They've put the malicious packages project in place. So with that, they will define what are or are not good malicious things from these public registries. So when we have something in our private registry, we want it to automatically check against that open API to say, okay, you have a package in your private registry, but it's deemed malicious by this organization. Do you wish to continue with it? Of course, you would say no if it's deemed malicious, or at least with a high level of scrutiny. And we need to think about that as well for all these new AI technologies that keep appearing. So, open source malware, which is another thing separate to OpenSSF's project, they now deem these AI skills in the same category as software packages that come from public upstreams. They deem it in a case that any person can create a skill. Therefore, every hacker out there can also do the same thing. And because of that, you are now in a wild west of skills that you don't understand how the code works. How could you possibly know if it's malware or not? So yeah, we definitely need kind of static guardrails in place to say, these are the things I have, check them against public APIs and say, do we know if it's safe or not? And then how do we proceed? Otherwise, we're just consuming from anything, anywhere.
How do we have this conversation with the developers, many of whom are, shall we say, nonconformists and have skills, and they'll just spin up a server in their basement and start writing some code on something, and then when they like it, they'll upload it into something that feels more like a standard corporate DevOps workflow. But as far as anybody knows, it was created with some level of alleged oversight, but maybe not so much. So how do we kind of get everybody on board?
Yeah, it's true. Like, I love Anthropic's wording when they talk about Claude, where they say, essentially, it's not truly agentic because even though it can do things, there should be a human that's in control of this. At least from that level of control, they're the ones making the ultimate decision. Do I apply? Do I even push this thing into production? It's not hands off totally. I think those projects that we saw recently, the likes of Claudebot, this fully agentic system, I think those are still very much pet projects for now. To your point, anyone can have a home lab running in their basement. I can run this tool as open source, completely free. I can run on a Mac Mini. That's what everyone seems to be buying to run it on its own, lightweight. But when we do that, again, it does or doesn't do what I expect it to do. Would I replicate that thing in my home lab and then put it in production for my company? Probably not, and I think that is where we're at today. It's that a lot of these things that seem scary, are we actually using them in production? I think we're so far away from that today because we have to look at non-deterministic systems and think, okay, how is it going to be used? A perfect example is you want a consistent response to happen to customers every single time that sounds good. Well, just by definition of non-deterministic, it can't determine that it will give that same output unless we put some human guardrails in place, like system prompts to say, in these conditions, always give the same thing. But when you start doing that, it's going back to what we were already doing, which was coding and saying, here are the hard-coded rules of how you respond to things. So I think organizations, developers still have to go through heads of engineering, platform engineering, whoever it is that sets the controls and standards. And they draw up at the end of the day the design for how we're going to use these AI tools. Something like a Claude, it makes sense. It's something that's running in your environment to help you be more productive. But in regards to these agentic systems, I think companies really have to look at themselves and say, what are we trying to build at the end of the day? What problems are we trying to solve? And if it doesn't solve a problem, how do we actually go about using it, or do we use it at all? But the security is a big part, until we know how we can consistently secure it, can we really put it into a highly regulated environment? Probably not. So it's an interesting problem.
So does that create something of a paradox where we're writing more code than ever faster, much of which, after it is checked in, isn't making it into a production environment because once it gets reviewed, it's determined to have all kinds of flaws in it. And so we just kind of create this endless hamster loop to no point.
Yeah, I absolutely. You're hearing more and more companies coming back with that feedback of, okay, we fully speed up process. Like, I don't think writing code was ever the problem. I think it was designing architecture that matters and is efficient for organizations. So yes, these toolings create more code than ever before and faster than ever before. But at the end of the day, if something goes wrong and you haven't wrote the code and you don't understand how the code works, you're going to spend twice, if not longer, as much time reviewing it, making sure, okay, how does this nested loop system work, and why does it work the way it does? Whereas when you wrote it and you didn't use an AI assisted code, and then someone said, well, this function's not working, you can say, well, I wrote that function and I know why it does this because I wrote it. So that is a big problem. I think more and more organizations will only learn from experience, where you test it and you say, this workflow actually wasn't as efficient as we wanted. And it also comes back to the same problem as we talked about there with the AI, which is, what are we trying to solve at the end of the day? Was the issue writing code, or was the issue writing secure code? I can still see how AI is going to solve a lot of problems, which was, in the past, there was this tech debt problem that we write code and we can't write all the code out there. So we use software dependencies and libraries from public sourced registries, because there's no way we could write every single thing we want into our code base. But if you could use AI to essentially rewrite, some of that functionality without needing to use libraries, I can see a world where AI is going to reduce the amount of vulnerabilities in our code base. If we have implicit design structure in place where we start thinking about, okay, how can we make our code more secure, using AI to actually generate that code part, because again, writing code was never the hard part. It's just writing at pace, doing it efficiently was always a trouble.
Will we create AI agents to essentially manage the AI agents that are running the code? And that ultimately may be how we lick this problem, because we're going to have two sets of AI agents, or maybe 3 or 4 doing different jobs, but we're going to have to surround the AI agents writing code with AI agents to help manage and ensure that their workflows are followed properly.
Yeah, again, that is a world that's possible. I think it would be highly expensive as well, because you got to think about as well, if we're using these tools that have an API and we have rate limiting, or we have, for instance, we're charged for the credits that we're expiring. Can we build a whole ecosystem where it's just agents that we're paying for to do that? Probably not. I can see a world where we have more considerable design consideration. So where we say, look, we're building a code base where we only want to use these programs, these dependencies, the things we trust. Again, that's something that Cloudsmith can solve, where we say, well, developers only source these things and anything else, we don't trust it because it's not part of our original design. And then there's other static controls in place where you say, for instance, whether it be a policy in Cloudsmith or a policy elsewhere, saying we only trust these file formats, these dependencies, these whatever it be. You are made very explicit about the things you do and don't approve. Everything else, again, implicitly would get denied. I think that's probably a better world than having the AI be the gatekeeper of more AI necessarily.
Mm-hmm. So to your point about all that, do you think that there's going to be auditors soon who are kind of like, rubbing their hands together with some level of excitement, going, hey, I can't wait to scan all this code and find out all these ways to levy new fines?
Yeah, I definitely think so. I think a lot of testbed projects are now showing up in production that, let's say there was a global race to get AI tooling out there to market, so people can say, look, I'm an agentic leader, please fund my project. But you have to wonder, in that pace, were they thinking about security? Was that the primary focus? Probably not. And we've seen that with other industries as well. We see that with smart devices, that it was such a rush to get gadgets out to market that could monitor your health and well-being. Turned out a lot of those were insecure as well. So I don't think it's a uniquely an AI problem. It's more of an industry and market problem.
All right, folks, you heard it here. AI coding tools might just wind up being one of those things that's too much of a good thing. Hey, Nigel, thanks for being on the show.
Thank you very much for inviting me.
All right, and back to you guys in the studio.
There's no doubt that AI will deeply impact enterprise software, especially as agentic AI rises in importance. But it's really an additive process. This episode of Utilizing AI features Amit Zaveri of ServiceNow, Nick Patience of the Futurum Group, and John Swartz of Techstrong. considering the future of enterprise software. Welcome to Utilizing AI, the podcast focused on practical applications of artificial intelligence from the Futurum Group. Every Wednesday, we explore news and use cases of the ways in which AI is transforming enterprise IT and the industries it serves. I'm your host, Stephen Foskett, president of the Tech Field Day business unit here at the Futurum Group. Before we dive into this discussion, let's meet who's on the panel today.
Hi, I'm Nick Patience. I'm the AI platforms lead at Futurum Research. I focus on enterprise AI, both at the application layer and down at the infrastructure layer as well.
Hey, I'm John Swartz. I'm the West Coast Bureau Chief for Techstrong, and which is part of the Futurum Group. I write about AI, I write about IT, and write about digital CXO, and it's great to be here again.
Hi, this is Amit Zaveri. I'm President, Chief Product Officer, and COO of ServiceNow. I've been working in the software space for 30 years and really excited about having a conversation about AI and software.
Well, let's dive right in then. We have heard many people say that AI will mean the end of enterprise software, that somehow AI is going to be an all-singing, all-dancing platform for basically everything that enterprises use. I disagree with that. And Amit, I think you probably disagree with that too. Let's start off by just kicking off. What is your reaction to that whole sentiment?
Yeah, no, I mean, there's definitely a lot of this conversation about what AI does to enterprise software. And I've spent 30 plus years in enterprise software, and I know how complicated and what it takes to run a business. And there's a huge amount of context, huge amount of understanding of a business processes, as well as kind of governance and security required. So there's a decent amount of understanding which you need to really bring in when you're running an enterprise business out there. AI is a very good technology enabler, as well as an opportunity for us to redefine and re-architect the products which we build today for enterprise software, because it adds a lot of value. But having AI replace everything enterprise software does is really not possible. And we've seen this on a day-to-day basis. I mean, LLMs have come a long way today, but today not a single company runs just on standard LLM. They do require a huge amount of context and huge amount of capabilities, which is built around those AI building blocks. But there's work to be done, and that continues to happen. And enterprise software will continue evolving to really make sure we deliver what customers need without just saying that AI will take over everything out there.
So, Amit, you've led the transition to the kind of agentic AI era at ServiceNow. So, how do we move from AI that simply suggests actions to AI that has agency to actually execute multi-step workflows across the enterprise without constant human hand-holding?
Yeah, no, I think you're right. I mean, there is an opportunity now with agentic to automate a lot of the business processes. There's always been this interest in enterprise software to automate and remove as much human interaction as possible. And agentic and AI turbocharges that for sure, right? So the way to think about this is you think about a business process. What are the pieces of business process which you can now automate using AI? But there are a lot of deterministic capabilities also required, because what AI does is gives you a probabilistic answer. Now you wrap that around with the data you might have for years in terms of running workflows, like what we've been doing at ServiceNow for 20 years. What we do with this probabilistic kind of workflows or agentic workflows is add the data element and say, hey, is the outcome accurate? This is what you're supposed to do or not. And if it's not, you go back and redo things or bring in a human into the loop as needed. But that has to be done end to end, not doing pieces of it. So when you look at a business process, any of the standard ones, right? Order to cash or procure to pay, or things you might be doing for IT service management and other things like that, you require the combination of what a context is, what the data associated with the particular outcome is, and then AI enabling and kind of making some part of the decisions, but it cannot take over the whole thing without having some data associated with what the outcome should be, with what we should have expected from that. So that's really what we're seeing now. And agentic processes are very powerful. It does reduce your costs. It makes you more agile, as well as it gives you some ability to improve how companies run. But you need to wrap it around in many, many other things as well.
So, Amit, your appearance is pretty fortuitous. I mean, today, the day we're recording, you announced this expanded strategic collaboration with OpenAI. I wonder if you could go a little bit into it. I guess ultimately what you want to do is deliver advanced agentic AI to enterprise customers. With part of this mad scramble among all the companies in terms of their workflows. Can you maybe discuss a little bit about what specifically this addresses and how impactful you think it may be?
Yeah, so we've been working with all the frontier model company providers for many years now, and we have been always an open ecosystem. So the work we're going to do with OpenAI, which we've been using them as the one of the large language model choices for our customers. In the first phase, we were doing a lot of summarization and giving ability for people to comprehend what happened as an action. The next phase, as we evolve some of those capabilities, is to really now use large language models for voice capabilities, for example, multimodal, multilingual, so that we can understand what the user is trying to say. But the intent in terms of knowing what the context is and then be able to action that, that's really the IP ServiceNow has been building for many, many years. So we still use these large language models to kind of take out some of the mundane pieces of our work and understanding a lot more of user data faster. And that's the relationship we've been building with OpenAI. We do the same thing with Anthropic in some cases, and we do that with Gemini. But our goal always has been to use whatever technology is out there and the advancements in there, but then build a lot of IP around it to make those things much more efficient, much more context-driven, and much more valuable to a customer. So we're doing this for now, say, employees, right? Understanding that employees are requesting help. What does that help mean? If they're requiring a fixing of a VPN issue, or they're requiring a new laptop, or they want it to be onboarded. Once we know what the request is, we know what that needs to happen, because we've been doing that from the back end, from an agent perspective with human agents before, now with AI agents. And OpenAI helps us now take that data and wrap it around to integrate with various different systems. But then our agentic processes and things we build in our AI platform is now doing the actioning part of it as well. So that's the relationship, and we keep on evolving that. But there's a lot of good technologies coming out, and we use that as a building block. And I would say 5 to 10% is IP from them, and 90+% IP has been built by ServiceNow to really get you the outcome customers want, because customers shouldn't care what you're using underneath the covers. It's really the outcome-driven kind of mindset.
Yeah, that's really important with a solution like ServiceNow, because you are reaching far beyond the technical IT staff. And I mean, really, this is a solution for the entire business. So having it be able to handle multimodal interaction, which, as you said, voice, video, things beyond typing and certainly well beyond coding, is really consistent with the goals that the company has had since the very beginning, which is to make this sort of process automation applicable beyond the typical enterprise IT staff, and really useful in the entire staff. And that's something I think that generative AI is particularly good at, is acting as sort of a user interface. Nick, this is something that we've talked about quite a lot on the podcast. What's your reaction to the direction that ServiceNow is taking?
Yeah, I think it makes a lot of sense. I mean, it's an interesting to watch a fairly mature software company like ServiceNow. Obviously, there's other companies that have been around longer, but you're very mature now. Adopt AI in a way that actually speaks to some of the problems that the companies face, and also obviously you're not trying to boil the proverbial ocean from day one. It is very much you understand your use cases extremely well. But your use case is also expanding a little bit, aren't they? Beyond the kind of the IT operations into HR and into other areas as well. So I think it struck me as a fairly pragmatic approach. And I guess you came from, you had a long time at Google and Oracle as well. I mean, how does that kind of experience, how has that informed what you've been doing at ServiceNow for the past I guess almost 2 years now?
Yeah, no, I think as you point out, I mean, we have expanded our use cases in quite a few areas, right? So what we did when I joined, I made sure that one, we are very clear about the customer outcomes. What we're trying to solve for. What are the areas where we can be differentiated as well as value added to our customers? So we did a lot of prepackaged agentic flows and say, you know what, customers, if you're doing this currently deterministic workflows, can you replace that with agentic while I guarantee you an outcome? And that resonated a lot with customers. Second thing we wanted to do was really think about controls. be it around governance, security, auditing, and giving a customers visibility in terms of what they're doing with AI. Every customer I spoke to and every C-suite member I spoke to, they were worried about proliferation of AI technologies without any idea what happened, who did what, and who's running what, right? And that doesn't work in enterprise software. This is not like you can just click to a different website and start using something else. You have to make sure business doesn't come down, or also anything which is outcome which is wrong, and it really impacts your financial standing and everything else. So we had to make sure that we're building that controls, providing governance, providing all the scaffolding required, and guaranteeing customer confidence. As soon as we gave them a lot of this thing, and we launched this product called AI Control Tower, which allowed you to get visibility, lifecycle management of AI technologies, ours and third party, as well as the ability to now audit and do risk management. Once we gave that to a customer, they started doing a lot more agentic use cases after that because they got that worry out of the way. So my experience at Oracle, my experience at Google, we really understood that AI, at Oracle, of course, I understood what enterprise software means, what it means to really run large companies' business without having any kind of wrong outcomes. Google gave me a very good grounding in terms of what AI is capable of, what you can do with it, and it's a really amazing amount of IP being built there. But combining the two is very tricky. And that's what I think ServiceNow has been able to do a good job of, is really taking AI building blocks, using that as a technology provider and using it where it makes sense, but then really building the frameworks around it and making it easier for customers to get value out of it. So our AI Control Tower, the agentic workflows, the connectivity with third-party systems, using AI agents, what we're doing from the perspective of understanding intent. And it could be in any domain, right? We're doing it for HR, we're doing it for finance, supply chain, procurement, and now expanding it to CRM, and then security and risk. Those things made customers much more comfortable that we're looking at it end to end. We call ourselves the enterprise operating system because of that. Like going east to west and north to south. We are just not a verticalized stack, but really looking at business processes which cut across. And that has been the game changer for us in most of the customer conversations. And that's what we're bringing to the table to our customers. And they still feel very excited about what we can do for them.
So if you can indulge me for a second, there's no question AI agents are going to be integral. They're absolute necessity within enterprises. But we've kind of gone through this timeline where there were a ton of announcements, including many from ServiceNow in 2025. And I'm first kind of an observation that I'd like you to address, and then I have a question. The observation is, where do you think the adoption of AI agents are now, and what are the real risks for enterprises that try to adopt AI without modernizing or integrating their core systems?
Yeah, no, I think there's been, of course, a lot of promises out there. And as you said, there's a lot of announcements. What we've been very happy about and very excited about is the adoption we've been having with our Now Assist product. We have delivered that early last year. And as soon as I was talking about earlier, this AI Control Tower, once we gave that to customers, they started feeling more comfortable going to agentic use cases. And I'll give you an example of companies like Bell, where they've been able to now use all of the customer service, our AI automated agentic flows for doing deflection, but also understanding intent and resolving issues. So I'll tell you the common use cases we see in adoption-wise: incident management, resolution of any kind of request, things like triaging, coordination of any kind of issue they might have run with disputes, like things we're doing with Visa. When a customer requests an issue with their credit card bill, having that been automated between a merchant, a credit card issuer, the consumer, and Visa in an automated fashion, and reducing the friction around that has been a game changer for them, because they're reducing cost using AI agents. But it's an agentic flow, not just an AI agent talking to each other. Right? What we have introduced recently is this idea of taking out L1 support for any IT-related requests. Right? So autonomous IT, we call it. And that really changes the game for a lot of the companies, because a lot of these questions and requests they get, we can resolve it as an agentic employee in a way, who's doing all the work for the request and resolving it thing without having to really file a ticket. Even if you file a ticket, we resolve that without having human interaction. So that are all use cases we're seeing live being used, and we have customers across the board who are adopting it. Last quarter, we announced the adoption rate went up 55x in terms of the amount of calls we're getting back and forth between our AI systems and the agentic use cases. So adoption is there. There's going to be turbocharged this year, I think. But there's a lot more comfort in this area from our customers than probably previously out there.
So, Amit, there was a late 2025, ServiceNow made its biggest acquisition ever with Armis and also bought Visa or Veza. I guess it's Veza. Veza, that's right. So this kind of, I assume, signals that you see security as a foundation layer for AI and agentic AI in particular. So why was it necessary to make those acquisitions now, especially Armis? And what does it say about the kind of future product direction for ServiceNow?
Yeah, I think we do believe security. And so I don't know how many people know, ServiceNow has $1 billion plus business in security already. We've been building out a security stack and portfolio, especially in post-breach. Anytime an incident happens, all the lifecycle, CISOs depend on ServiceNow to manage that. We integrate with Palo, we integrate with CrowdStrike, we integrate with Wiz of the world to really manage the lifecycle of any incident and resolving it and then managing the auditing and everything around it. We see a lot of customers asking us for now, one, how do you manage the identity of the user? Especially now we go into non-human identities, be it AI agents or devices. So the Veza basically does identity governance, which has been a big kind of use case for ServiceNow already, because all the employee, when they join a company or an object you add or asset you add, the lifecycle goes through ServiceNow typically. So Veza was a very natural extension for us to giving this identity governance for especially non-human identity. Second thing with Armis, what we saw was IT and OT starting to come together. What Armis does is provides OT security, the operational technologies. So any kind of manufacturing, be it devices, robotics, be it IoT devices, how do you secure them? So when a lot of what ServiceNow has had is a product called CMDB, which tracks all the assets inside a company, hardware and software assets. That's becoming kind of the gold standard for companies to know what's inside their enterprise and how to manage them. So security around that is becoming very critical. So customers have been coming to us saying, hey, you already know our assets. Can you really make sure that there are no breaches associated with that? So vulnerability management, as soon as you get signals, and then again, the exposure management around that is what Armis does. So combining IT and taking it to the OT environment and making it end-to-end, because IT teams are really managing the OT environments for manufacturing or any devices they might have inside the company. Give you an example, JP Morgan Chase. The new building they put in, they have so many devices, IoT, wireless, other things like that. The security associated with that was all been done by Armis. So we manage that asset, then the life cycle, any incident happens, goes to ServiceNow again. So completing that life cycle was very critical for us because the customers are asking for it. We're giving pieces of solution, not end to end. And as we move to agentic, you have to think end to end. You can't just do pieces of it again and it has to be some partnership and some things we have to build ourselves. So Armis and Veza closes the gap for us and really expands our capabilities. And it really plays into the idea of having an open ecosystem with third-party systems while we help them manage that life cycle for any asset associated with that. So that's the reason why we bought those companies. It adds a lot of domain and really expands into the security space, which we believe we've been doing very well, and our customers are pushing us to do more and more.
Yeah, I'm glad Nick asked about cybersecurity and I didn't realize how large your security business is also. So I'm glad you pointed that out because that's something that kind of goes underneath the radar. And in a sense, I always think there's a gap. And maybe this is one of the reasons why there is kind of a slow adoption of agentic AI or a reluctance among some companies because there's that whole security issue. And that's something that when we do Techstrong Gang, and Stephen can vouch for this, that point is hammered home that security slowly evolves rather than is revolutionary. And AI definitely is revolutionary. So there's this gap between the adoption of AI and the urgency of now versus the consequences of a security issue. And I'm wondering, do you think that's still a significant issue or will continue to be a significant issue for enterprises that are thinking of diving whole hog into agentic AI?
Yeah, you're right, John. I think without security, without having a confidence in security, confidence in risk management, and tracking what AI is doing, there will be reluctance to adopt AI in enterprises. I think the other parts of the world might be okay. So if you don't solve the foundation, have AI built with cybersecurity in mind and the ability to control it, I think customers will be very wary about not knowing what is AI doing into their environments, right? And that's why we are doubling down on building a stack, our platform. We still have this concept of one platform with one data model, one user experience, as well as one kind of end-to-end architecture, bringing AI, bringing security built into the platform, not a bolt-on, not something on the side. And that has to happen. I think whoever wants to succeed in this space has to really think about that as ground up, as a P0, and then build everything around it to really make our customers successful. And that's the foundation we've laid down, and it has resonated with our customers, and they're getting a little more confident as they continue down the journey. AI is going to stay here. It's going to be a game changer, but you have to do it thoughtfully, and you have to do it in a way where enterprises can benefit and not really get into risky environments, which could really crumble their businesses.
So, Amit, we talked earlier about the OpenAI partnership, and that's obviously fairly hot off the press. But you also have this partnership with NVIDIA, with its the models, the April Nematron models. I'm just curious about why why domain specific models and why reasoning models like that one are better for a kind of service desk environment than say a general purpose LLM.
Yeah, I think a few things. One, see, OpenAI and other large language models don't run in sovereign environments. They don't run in on-premise. We have customers which deploy software in many ways. Public cloud in our data center, as well as in private cloud environments, as well as sovereign cloud environments. So we have to cater to all those different kind of deployment models. And that's why we want to give customers choices in terms of what they can use as a building block, which might meet their security requirement, but also deployment requirements as well. So what we're doing with NVIDIA and April has been pretty impressive in terms of what we've been able to build from those domain-specific models, is to kind of take some use cases. Hey, we can use this in this particular use case without needing a large language model or a frontier model in a way. And also it'll meet the sovereign or any kind of deployment needs customers have. So that's why we keep on having that investment going to ensure that customer choice is prevailing. But also we understand what is the art of possible in many, many different cases. And can we reduce costs? Can we give you better outcome? Can we compare to different scenarios? Can we do do a better prompt engineering? So it also helps our engineering team get better when they kind of mix and match things and really get the best outcome for our customers as well. So we'll continue that path, and we'll ensure that customer choice remains and it prevails long term.
That makes sense. Just a quick one on sovereignty. You mentioned it as one of the reasons for that partnership. So are you seeing that as an increasing concern for CIOs across your customer base? Is it a geographic specific thing still, or do you see it all across the world?
No, we're seeing this globally, right? And it depends on the industry as well. So it's more industry driven than a particular region. But I think, as you've seen with some of the geopolitical tough stuff going on in the world right now, there is a lot of requests now coming from countries outside US who want to run their own specific environments. And they don't want to completely be on a public cloud some cases, or they don't want to be outside their particular country. So that requirements are pretty common. It's gone up over time than it was probably a few years ago. We're seeing it by regulated industries as well. So if you look at public sector for sure, but banking, we see this in some of the things around manufacturing and other areas where it could be very specific use cases. They don't want the data to be outside their particular domain. So that use cases keep on emerging. There are a lot of local providers we work with in a particular country because those customers in those countries want to depend on those local providers as the infrastructure providers, and we want to make sure we support that as well. So we run on all hypercloud providers. We run on our private data centers. We run on customer data centers. We run on a lot of those now, I would say, it's sovereign providers in some countries as well. So we've been always thoughtful about what our customers need and where we want to be to meet them there.
You probably already touched on this, but I kind of want you to go a little bit deeper on sovereignty. I can't pronounce that word for some reason. But can you maybe talk a little bit more about that?
Yeah, the sovereignty, I think the way to think about is one, there could be multiple levels, and we can spend hours talking about it, because it starts initially first is data residency. You want to make sure data doesn't leave a particular region or a country, right? That is usually P0 for many customers. Second is who's touching the data. So once it's not leaving the country, who's running and operating that environment. So it could be citizenship of the people who are involved with that particular data center or the infrastructure. Third is that what are you interacting with systems? Who is the provider? So that could be another thing. The fourth is, are you going to connect to anything outside? Is it completely disconnected mode in a way, right? So that there's no other than the customer's environment. So there's so many different levels of sovereignty requirements, and we have to cater to very different needs depending on what the use case of a customer is. In some of the government and work we do, those ones are much more stringent. Some of the industry specific, like banking and all, may be regulatory driven. So you need to kind of address those requirements they come up with. It's usually around data, access, people, systems, connectivity. So various things, and they get more and more complicated as you go down those conversations. And that's why you need a lot of good local partners, as well as you need software which is flexible. So you don't have to keep on rewriting it. So you have to architect it in a way that is one, very flexible in terms of how it's deployed, but second is very secure, and it gives you controls. So you have to have visibility. And this is where I think when you talk about AI, a lot of those things are always missing. Large language models and things like that have no way to give you controls. It does what it does, and there's no split brain, right? This is one thing, and it does everything. And you land up not having idea what happened behind. And you cannot have black box also in sovereignty. You need to know what was touched, when was this touched, who made changes. All that whole attribution needs to be required as well. So those are the sovereign requirements. So they're getting more and more complicated. And that's why we get companies like ServiceNow are liked by our customers, because we understand that complexity, and building enterprise software requires a lot of mundane stuff to be done, but complexity is always there, and you can't ignore those things.
Yeah, it's really kind of a refreshing and realistic message. And I think that enterprises are going to be more, they will be rushing to embrace this sort of approach because it's more mature. I mean, sometimes in the AI space, there's a bit of a sort of fast and loose, break things and see what happens attitude. And that is not at all compatible with the kind of customers that major companies like ServiceNow have. And frankly, with most of the customers that I speak to as well, I think a lot of them are very wary of AI and the messaging that you're putting out here, that essentially this is a powerful tool. It enhances the abilities that we already have, but we recognize that there's a lot more than just throw AI at the problem that needs to be done. So I guess to sum up here, again, this is utilizing AI. We're supposed to be very practical here, and that's what I'm hearing from you. Let's sum up your message here. I mean, if a customer comes to you and says, "Oh boy, that AI stuff, how's that going to impact me?" What's your elevator pitch to that customer?
I would tell customers to be realistic, right? AI will impact you. AI is going to be important. Get used to it. Learn it. But learn it in the context of your business. Don't just do it AI for the sake of AI, right? It has to be part of your solution, cannot be the solution. So it's a building block. It's reinventing software stack, just like a lot of other technology changes have had done. This is probably more powerful than other technology changes, but pay attention to how it runs and operates your business. Don't just take a product out there and deploy it and then realize that your business will fail. So bring it as part of the overall solution, not the only solution.
You know, it's going to be interesting to see how companies think about this relationship between AI models, agents, and the enterprise architecture they sit on, and kind of what the rise of agentic AI in particular means for CIOs and tech leaders in practical terms. And it's going to be fascinating to see how where this path leads us, and if we fall into the same traps we had before with early cloud and SaaS adoption. That's kind of my takeaway, and I'll pass this on to Nick.
Yeah, it's been a really interesting conversation. I mean, we touched upon the idea that we talked about the OpenAI partnership, the NVIDIA partnership, and it just sort of rams home that point to me that models are, I find them super interesting, and they are incredibly integral to what we're doing in enterprise AI, but they're not the application. Yeah, the application sits on top, and it's ServiceNow and companies like ServiceNow that actually deliver the actual enable organization to realize the value out of AI. So this has been really interesting.
Well said, Nick. I completely agree. And thank you very much for joining us for this episode of the Utilizing AI podcast from the Futurum Group. Before we wrap up, though, let's give you all a chance to let us know where we can connect with you and continue this conversation. Amit, let's start with you.
Yeah, we have a big customer conference coming up called Knowledge in May, and please join us there. We'll have 20,000 plus people, practitioners who you can learn from and kind of share ideas. It's going to be a great time.
Oh yeah, I'm going to vouch for what Amit just said. I've been to that show several times, and it is fantastic. It's usually at the Venetian, I believe, and it's early May, right? Well, you can see I'm working on tech AI stuff. I'm on Techstrong Gang. I'm on this show. I use LinkedIn inordinate amount. I kind of shy away from X, and I've kind of given up on Facebook. Sorry, Facebook. But that's where I am, and I'm going to be writing about Davos and some of the political repercussions or the landscape there the next couple of days.
And I'll be focusing a lot on sovereign AI, and over coming months, as well as digging into the output from our decision maker survey, which is in the field at the moment. You can find everything I do on futurumgroup.com, and I'm on LinkedIn and X as well.
And as for me, I'm very excited to be leading our AI Field Day event here in May, so tune in for that. But in the meantime, thank you very much for tuning in for this episode of the Utilizing AI podcast. If you enjoyed this discussion, please do subscribe on YouTube or your favorite podcast application and consider giving us a rating and a review. This podcast is brought to you by the analysts and experts from the Futurum Group, where insights meet AI. For show notes and more episodes, head over to techstrong.ai, the Utilizing AI YouTube channel, or the Techstrong TV app on your television or phone. Thanks for listening, and we will catch you next week.
I'm Ted Weatherford, VP of Business Development at Xsight Labs, and my distinguished colleague.
Yep, John Carney. I'm a software architect on the E-Series, which is what we'll talk about.
And I'm just going to kick it off by saying the E-Series is a separate chip. It's a SoC, and we call it Cloud on a Chip because it's got all the elements of cloud. It's got the Ethernet connectivity. It's got security. Okay. It's got the virtualized storage. And of course, it's got the processing with the ARM cores, 64 Neoverse 2 ARM cores. It's in production in about 4 months, and it's been general available for 4 months. And these are just the different form factors you could get it in. Okay. We sell a server. We have one here to show you guys. And we also have the add-in card, and you can add it into the server. So the server has an add-in card slot or two in it. So we can put our own chip as a server and then a smart NIC together. And then we have the COMX. And the COMX is really targeting the control plane applications, but it's actually just a really nice embedded format that, well, you could have a 64 ARM core product on. John, take it away.
Yeah.
Thanks.
So the first thing I'm going to do is I'll talk about what the architectural differentiation is between our DPU and what traditionally has been the DPU offerings from our competitors. So the traditional DPU really started and evolved from a NIC. So what has happened in the past is the NIC would be taken, there would be some flexibility added within the pipeline of the NIC, and then to add even more flexibility, a CPU cluster was added to the NIC. And this is what our competitors' architectures look like as a DPU. And this architecture is constrained, and the reason why it's constrained is because the CPU cluster is not really sized, and the connectivity of the CPU cluster to the offload NIC is not sized so that all of the packets, all of the processing of the data plane could go to the ARM cores or go to the CPU cluster for processing. It really relies on being able to process most of the packets in the hardware pipeline, and only exception packets, or maybe the first packet of a flow goes to the CPU cluster. And what we found with this architecture is that for many workloads, there's flexibility that you need that doesn't exist in that hardware pipeline. And you often are trying to get all of the packets to that CPU cluster, and then your performance is limited. What we did differently is we started from that CPU cluster and we said, let's take a very energy efficient
and optimize for data plane applications, server class compute system, and let's size it so that all of the packets, and in fact, all of the PCIe transactions when you're attached to a host can all be terminated and processed in software using standard programming models, not proprietary programming, but just a standard Linux or user space programming. And so that's what we started with. And then we added to that an Ethernet unit, which provides the Ethernet connectivity and provides some processing that's done on sort of the throughput or the bits of the packet, like encryption. And then we added a P unit, which is the PCIe connectivity, which when you connect to a host or you can connect devices to the DPU, they go through the P unit. But again, all of the data plane processing can be done in the cores and not in this model on the left where you really have to do most of your processing in the NIC portion of this architecture. This on the right allows us scalable performance. We can scale performance with cores. And again, it's a very standard development model. And I think we can go to the next slide.
Yeah. The competition does it differently. They start at the offload NIC and they add ARM cores. And they traditionally, for 3 generations, haven't added enough ARM cores and haven't added the more powerful ARM cores like the Neoverse 2s.
Yeah.
So, and we're really vindicated that with the Bluefield, right? The Bluefield's come out and said 64 cores, and it's come out and said, okay, let's put a real compute in there. So we see them as our principal competition. The Intels and the Pensando AMDs are still kind of sticking to their guns with the other approach.
And your programming model on that solution is Linux?
Yeah, so we run Linux, we run, and we'll get into this more in some of the other slides, but we run Linux. We will be certified as an ARM system ready. Actually, we're certified as a server class, not an embedded class, meaning that any operating system distribution that can run on an ARM server can run on our DPU. And so we see, and we'll get into use cases as well, but we see use cases where customers want to do everything in the Linux kernel, all of the, networking stack of the Linux kernel. And we see a lot of use cases where customers want to use user space frameworks like DPDK or SPDK and do all of the data plane programming in user space. One of the big advantages that we have is that a lot of these data planes already exist. The customers have been running them on servers. And now what they can do is they can take those data planes that they're already running today on servers, and they can retarget them unmodified onto the DPU, and they get a huge gain in performance per watt, in density, to be able to put multiple of these E1s in a small form factor. And so that's really an advantage we have, is that all of those existing data planes that people have run on servers can just be placed onto the E1.
Go ahead, Jack. I'm sorry.
I was just going to ask, so on the traditional side, it's all custom code, right?
Yeah, so it's a combination, and the combination is what actually makes it difficult, because there's sort of custom code that runs in that offload NIC portion of it. It's usually proprietary. It's usually very resource constrained. And then there may be more sort of standard programming model on the CPU cluster. But to create an application, you kind of have to split the application between these two very different programming models. Mm-hmm. And that's what makes that that environment very difficult to program.
Yeah. I think it was also a problem in the security hardware market too, right? When I've got to do packet processing between the CPU and my offloading NIC, right? It's a huge issue, because I've got to have almost a 1-core application to do that kind of processing. So if I can put it closer, then it makes a lot of sense.
Right.
So in that case, then, because you're traditional Linux based, you can run into Linux things. So are people doing eBPF on this?
Yep, you can run eBPF. So we see that there's a camp that's sort of Linux, eBPF. There's another camp that's the user space, DPDK.
Okay.
And we support both, and I think we'll show that a little bit more in some of the future slides. So it's really, again, like, it's just, if you've programmed data planes on a server, this is just a very familiar environment to you. Okay, I think we can go to the next slide. So this is a closer look at the actual chip architecture. So in the heart of the architecture is that compute fabric. That's where our 64 ARM Neoverse N2 cores are. They're connected with a high-speed, scalable, cache-coherent fabric. We support 32 megabytes of system-level cache that's shared by all of the cores. The cores also have their own private L1 and L2 caches. We have a memory subsystem where we have 4 channels of DDR5 memory. Those can operate up to 5200. This is a little bit unique. Most DPUs don't have that much memory I/O. And depending on the form factor, Ted showed those form factors earlier. In some form factors where you're not as space constrained, you can populate all 4 of those memory channels. In some other form factors where you may be more space constrained, you might only populate 2 of those memory channels. But we give you that ability to use more memory I/O depending on your use case. A very unique aspect of this chip is our PCIe connectivity. So we have PCIe connectivity that could be host attached, where you connect the DPU to a host. That's a traditional kind of DPU application where we're acting as a NIC to a host. We did something unique where we, in hardware, created PCIe hardware that presents all of the services of PCIe to the software so that the software can emulate any kind of PCIe device. So to a host, we can look like a storage device, we can look like a networking device, we can look like an RDMA fabric device, and it's all software defined, again, using just standard programming models. We support up to 40 lanes of PCIe Gen 5. Some of those lanes are typically used for, like an NVMe boot or peripherals. But then there's 32 lanes, which would typically be used in your data path. That data path can allow up to 800 gig of PCIe bandwidth towards a host or towards storage. We'll talk more about storage later, or towards other devices. On the bottom of the diagram, we show our Ethernet, or we call it a E-unit. And this appears to the programmer as your NIC. It appears like a NIC. It appears sort of like an enterprise class NIC with the features that you would expect in a NIC. It also has several offloads. We support inline encryption. We have a lot of flexibility in what kind of formats we can support. It also supports all of the normal stateless offloads that you would find in a NIC, things like CRCs and checksums. It also supports lookups, and you can do some flow offloads in the NIC portion of this chip. And the way we think about it, and the way our philosophy is that Ethernet hardware is really there to help steer traffic to the cores, to enable you to scale the processing of those packets on the cores. So we're not trying to do all of the processing and all of the flexibility in the NIC portion like our competitors are. We're trying to do the primitive operations that you need there to enable you to use those ARM cores effectively. A little bit on power. So the chip itself, typical use cases would be, for typical would be 50 to 75 watts. And, for thermal design power, it's up to 120 watts. This is rated with a spec int of 170, which is a, significant amount of compute power in such a energy efficient chip.
And John?
Jack Pollard with Paradigm Technica. I noticed that you have a memory encryption block in front of the memory.
Yeah.
Do you support, so is it, you can support secure encryption data in use?
So we have like multiple different places where we do encryption in this chip, and I'll talk about them. So one of them is inline, as data comes in and out of the Ethernet interface. And so that's like your IPsec, or Google has something called PSP. Also, Ultra Ethernet has their own security. So all of those can be done inline. And if you can do them inline, that's really the best place to do it, because it doesn't require you to bounce the data through your memory system multiple times.
Sorry about that.
We also have a look-aside crypto engine. And so there's things like TLS, TLS, where you want to terminate like TCP traffic that has TLS. And it's very stateful, and it's not something that's easily done in line. So we have a look-aside engine where the ARM cores can kind of feed that look-aside crypto engine and do encryption there. Then we have the memory encryption. The memory encryption is really there so that data that's stored in the DRAMs on the chip can actually be encrypted.
Okay.
So that there's not any way you can kind of snoop on those memory interfaces and be able to, access any kind of sensitive data. It also ultimately can allow you to have multiple tenants sharing, cores on this chip, and be able to isolate, their data in a way where they're each encrypted from each other.
That's sort of where I was going. I was wondering if you could do a secure enclave in this.
Yeah, so I'm not really the right person to get into the details of that. We have security architects that could really answer all of that. Yeah.
Very quick question on your PCIe side. Is that capable of doing CXL interfaces as well?
So we did not implement CXL in this chip. We're not going to really talk about roadmap too much for this chip, but that's something that is very much in mind for us on our roadmap.
Okay, because there is some interest in the industry in the ability to actually have essentially NIC to CXL interfaces.
And this is something that we're following closely again, and
seeing that. We're seeing that. Memory for sure.
This chip does not support CXL, but stay tuned.
Yeah, the follow-on's called the E2. We don't have a roadmap slide on it, but sorry. Yeah, the follow-on product is the E2, and it's roughly double the bandwidth of this one, so it'll be a 1.6T-ish type product, above 1.6T or 1.6T, and that's where you'll see the CXL support come in.
Okay, I think we can go to the next slide.
Sure.
So we'll talk about some of the applications. Starting from this server class kind of architecture, you can imagine that there's a very broad set of use cases, and we'll talk about some of them. We'll talk about the ones that we've really been focused on. This chip was really architected for this use case on the left. We'll call it the front-end DPU. And this use case could either be just a traditional public cloud compute node. In that node, the tenants need to get access to the infrastructure. The DPU is what provides the virtualization of the infrastructure, the securing of the infrastructure, and for both networking and storage. And it provides isolation amongst the tenants that are running on the host. But the front end also applies to an AI cluster where essentially the same kinds of things have to be done for the AI cluster to provide access to the infrastructure, access to the storage. And in the, for the AI use case and both for the traditional cloud compute use case, the DPU is really offloading the host and offloading the DPUs from having to do those functions, and offloading it in a way where it's done on a very optimized architecture for those workloads that are running on the DPU. The backend DPU, so in the typically in the sort of training clusters, these high-scale training clusters, this back-end NIC function has traditionally and predominantly been done with the performance NICs. Those NICs allow you to get, RDMA performance at very high rates and low power. And there are opportunities in those large clusters for DPUs more around innovations, innovating around congestion control or congestion avoidance, packet spraying, telemetry. There are many, many use cases where even in a training cluster, the DPU makes sense. But really in the inference cluster is where the DPU can shine because in the inference cluster, that's where we start to see the offload of KV cache offload from the GPU to something else. And the DPU is a natural place to do that because it has direct access to the GPU's memory system, but it's also directly connected to the scale out network of those inference clusters. So as we see a push to building special purpose clusters for inference, there's a lot more opportunity for the DPU in those. We also have use cases for local storage. And in the local storage use cases, to the host, we can virtualize storage devices, but those can actually be, the E1 and the DPU can actually be managing a local set of disks. There's a bump in the wire use case, and this is one diagram. There's many ways to draw this bump in the wire, but you can think of the bump in the wire as just simply a network-attached appliance where packets come in, maybe come in on one port, get processed, go out another port. Many applications for bump in the wire, both in security, in software load balancing, and we see many use cases there. Smart switch is another use case that I think we'll touch on more later, where we actually combine the switch with the DPUs. What this allows is it allows you to use the switch to have a large bandwidth of traffic coming into the switch and to selectively choose which flows you want to go to the DPU for more processing. Typically, the switch is doing your stateless processing. And the DPU can do very stateful processing. I think we can go to the next slide, Ted. And then we have server use cases. So we have edge server use cases. We see a lot of applicability for DPUs for things like CDN. For gaming, we see use cases. And then on the right, we see the E1 in sort of an appliance form factor for storage target kinds of use cases where the storage is disaggregated from the host. This is sort of a look at our software developer kit. I've said multiple times, I think so far, that we're standard programming model, but we do provide software in a few forms. We provide the drivers and the necessary infrastructure pieces of software to enable our customers to use the DPU. And we also provide reference software for many of these applications and use cases. So at the lowest level, we provide the secure boot, the BIOS, and the sort of low-level software that gets the chip booted and operating. And then as far as the operating system, as I said earlier, any operating system distribution that can run on an ARM server can run on the E1. Internally, we've been using Ubuntu. That's kind of our sort of default. And then we provide the DPDK Linux drivers on top of that for our networking. And then as I talked about the PCIe, where we can emulate any kind of PCIe device, we implement what we call backends. So we implement a backend for networking. We have a couple flavors of that, VirtIO and XNA. We implement a backend for NVMe emulation. and as well as backends for RDMA and Rocky. And then as you go above that, you start to get into the applications. And typically our customers will use our chip as a platform, and then they'll put their own applications on top of the E1. There is an application that we've developed called Sonic Dash. We'll talk about that more in a couple of slides. And that's where we'll really get into some of the performance in a real world use case, SDN use case for the E1. Okay. Right now. So the reason why, we kind of selected Sonic Dash to talk about is because this is a very heavy workload, SDN workload. And so what is Sonic Dash? Sonic Dash is a Linux Foundation project that was started in 2021. It was really a project pushed by Microsoft. And the goal of the project was to take the stateful services that run on the host in the public cloud and define them and define the APIs and the object models in those services. And the goal of that was to enable a broad set of technology providers to really create performance and power and cost optimized implementations of these services. Traditionally, that cloud SDN had been built on frameworks that had primitive operations, and a service was sort of defined as stringing these primitive operations together in order to implement the service. And over time, as the cloud matured, it got to the point where we no longer need this kind of low-level way of defining the services in the cloud, that we could do it by actually, we know now, after decades of cloud computing, that these are the 7 services, SDN services, that you need in the cloud. So they've been defined, and we've been implementing them. One of the services is called VNet to VNet. What does this do? So packets come in, you apply lookups, transformations to be able to map the overlay to the underlay, does state tracking for TCP and UDP connections. Dash defines that you have to do 5 ACL operations. Algorithmic ACL is a very intensive, especially at high scale on memory accesses. Accounting, enforcement of rate limits, flow scale limits, and also you need very high availability because if you're tracking millions of connections, you need to make sure that that state is synchronized on another data plane. So if there's any kind of failure in the network, all of that traffic can be taken over by a peer data plane, and so there's no loss of connections to the users of the network. In order to run Sonic Dash at an 800 gig scale, it requires millions of routes, millions of prefixes in your ACL tables, millions of mappings. The point of showing this scale is that this kind of scale is not something that you can fit on chip memory. All of this has to live in DRAM off of the chip. And there's also no locality. As packets come into the chip, a packet might be for one flow, next packet's for a different flow, and you can't rely on those caches for locality. Everything has to go to DRAM in order to be able to process the packets for Sonic Dash. It doesn't matter what architecture you have. It doesn't matter if you have like the E architecture or one of our competitor architectures. It's a very DRAM intensive use case. So if we go to the next slide, we can show that there's a test defined for Dash called the Hero Benchmark. It's the highest scale, most intensive test that you can do. The test requires that you have over 120 million background connections. So this background traffic is running. And then while that background traffic is running, you have to be able to support 12 million new connections per second. And you have to be able to do that for 100 seconds without a single packet drop. We, on the E1, have been able to exceed that performance. We were able to get almost 20% excess on that performance requirement. We're able to do it where we still have cores left over, so you can run those remaining cores for your sonic control plane. And even with the performance we were able to achieve, we still see the potential to achieve even more performance gain, or be able to do it with fewer cores. And we see like the potential for another 25 to 40% performance improvement over what we've already tested. So this is just to give you an example of a cloud SDN use case. It's really the use case that we designed and architected the chip for, and to show that we're actually the only DPU that's able to pass this test at 800 gig with a single device.